Now that we know what a statement is, let's go ahead and take a look at quantified statements and negations. So first, let's go ahead and define what a quantified statement is. And it's fairly easy to define. It's something that contains the words all, some, no, or none. And those words are actually called quantifiers. So I'm going to say that these are quantifiers. So those are the words that make it a quantified statement. So let's take a look at a couple examples here. So one example might be all poets are writers, right? Right now we're not worrying about if that statement is true or not. And then our other statement here is no people have died from taking math class. Okay, so those are two examples of quantified statements. So what you want to do is real easily is just underline that quantified statement. Well, let's go ahead and see what this means. So I'm going to go ahead and pop over to my highlighter here. When I say all, I have this group B here. This group B is some kind of bigger descriptor, right? So let's say this is the kingdom of animals, right? And then we could say that all humans fit within that kingdom of animals, right? So in this case, it's a scientific example. So everything that is in A is in that category of B. So the way that we would write this out from a logic perspective is all A are B. So in this case up here, all poets are writers. B would be our writers. And A would be our poets. Okay, if that was a true statement. Now, there's also what's called an equivalent statement. An equivalent statement. And an equivalent statement means the exact same thing. It's just worded differently. So an equivalent statement to all A are B would be there are no A that are not B. So essentially what we're doing is negating both of them. And it gives us the same thing. In future lessons, we're going to talk about whether something is considered an equivalent statement or not, or if a statement would be considered true based on certain statements that we have. All right, let's take a look at some. Some is a little bit tricky because we're going to have to take this guy and divide it in half, both in its original meaning, and then when it comes time for us to negate it, we're also going to have to look at that here. So let's look at, I'll make A blue. So A is going to be some category, and then B is going to be my other category. And you'll notice that there is a point on this. It's called a Venn diagram, V-E-N-N. You'll notice there's a part on this Venn diagram where there's an overlap. And in that overlap, that means that A and B are actually sharing that area. So that's the area that we would call the sum, right? So if we say that some A are B, we're talking about that overlap area right there. So there's two ways for us to say it. We could say some A are not B, and so that's really pointing to this point of it. Or we could say some A are B, and we're pointing to that yellow area. For an equivalent statement, right, I'll put that in red here. Not all A are B. And then an equivalent statement of some A are B. There exists at least one A that is a B. There exists at least one A that is a B. So we're saying that there's at least one in the category here in that yellow zone. All right. And so then we're moving on to no or none. And no or none, we're talking about value of A here and the value of B here, and they're completely separate. There's no overlap at all. One is not contained in the other, so there's no crossover at all. So we would say no A, R, B. You could also shift it a little bit grammatically. There are none A that are B, right? So that's where no and none come in. Now your equivalent statement is going to be all A are not B. All A or not B is our equivalent statement. All right, so now what we want to do is move down to our negating quantitative statements. So remember up here we had all. Well, if we have all, right, then the negation of that is actually going to be some A are not B, meaning that there's a little piece of this category that's on the outside of that circle of B. So notice we have a little bit of an overlap here of some A are not B, some A are not B. So what do you think the negation of that first statement is going to be? If you guessed that we're talking about all A are B, you absolutely have it right. So all A are B. And how we know that is that we know that this statement and this statement are the same. So we've had some kind of crossover between these two sides, if you want to look at it that way. Now we got to look at the crossover of the other two sides. So that's why I wrote them in that specific order. So if we have all A are B, the other way we can negate it is to say that no A are B. And you'll notice here, right, no A are B, no A are B. That crossover is happening here. So I'm sure you can assume what is going to go into the negation of the no, which is going to be some A R B. Okay. All right, that does it for the notes. And what you're going to be tasked with is going ahead and taking a look at the quantified pieces here. So all dogs go to heaven, some houses are yellow. I would recommend that what you do first is you underline all of your quantified statements. Okay, those are pretty easy to do. But you have some that are and some that are not. So don't be afraid to come back up here and take a look at, okay, what's going to happen based on where it's located as far as negating that. So I'm going to go ahead and let you take a look at that, and we will go ahead and do the response to this in another video so you can check your work.